We did all of this to make it possible for the 3 of you new arrivals to follow this content. And I'm looking at you, camera, online viewers. We are very sorry for the inconvenience. Let's kick off. Once again, half the way. For those of you who are criminally unaware of the Azure dev community, the entity in whose name this very event is happening right now, we have 2 types of sessions, changing each time. We have recurring news and topics events and AMAs, where our cloud native experts and subject matter experts help you out with guidance on your current projects or best practices that they did before. Links to these will be provided 3 slides from here. We also have the Developer Community Hub. For questions on that, please grab Torsten afterwards because we are out of time, or join it and contribute if you like on your own peril. Last but not least, we keep people posted via our LinkedIn group for the Azure developer community. I'll leave this slide open for some additional disturbingly quiet seconds so you can join using the QR code. Thank you. Amazing. Events are coming as well, and we would like you to join. The upcoming aforementioned community calls will be happening February 2nd. This will be an AMA on container apps, and on February 16th, we will have Azure Mission Critical news and hot topics. Also, the dates for this very reactor in Berlin are set. The next one happens 1 month from now on February 16th. We will be covering the mastering of applications at scale using Azure. For the March date, we are yet to find a focus topic. By the end of tonight, I'll be asking you for your opinion on this while we are having a beer. Feel free to come up with ideas from now. Move. Oh, here we go. If you want to stay up to date with our meetups, there is a dedicated meetup group for this. And if you can't keep up with all the QR codes, we are actually recording all of this, even the painful process leading up until this point, and we will be publishing it via our Reactor site at reactor.microsoft.com, meaning you can find past sessions as well. Feel free to have a look. There's very valuable content there, and it's free. Feel free to check that out. One last event I want to inform you about is the Azure Fundamentals Adventure Day on March 15th, happening in our Munich headquarters. It is part of the happening Azure Solution Summit, so you will have the chance to meet all the important Azure personnel of Germany and the surrounding. The registration will be open soon, and the capacity is limited, so make sure you remain on the lookout for this. Additionally, we have some news on the Azure product. First thing is that we have the Azure Application Consistent Snapshot tool, in short, ASAC Snap. This is a command line tool that enables data protection for third-party databases by handling the orchestration that is required to put them into an application consistent state before taking a storage snapshot. The benefits of using ASAC Snap include, but are not limited to, application consistent data protection, ad hoc volume protection, and it enables the space-efficient cloning of storage volumes and support for after the snapshot, it returns them to an operational state, so it doesn't disturb your overall process. Secondly, as an update, we have the ADX update. It now supports managed ingestion from Azure Cosmos DB. This enables near real-time analytics on Cosmos DB data in a managed setting, meaning ADX data connection. Since ADX also supports Power BI direct query, you can now also have near real-time Power BI reporting. We are talking about sub-seconds latency here if you use streaming ingestion. However, at the moment, only Azure Cosmos DB NoSQL is supported. More coming soon. Also, we have a new Visual Studio preview online as of yesterday, if I'm informed correctly. This release contains some new productivity improvements, most of them directly requested by the community, which means that your feedback actually matters, so keep it coming. As today's Reactor is a .NET afterparty, let's start with the .NET updates. We have support for HTML code actions in Razor files. We have Razor and Roslyn performance improvements, obviously with each update. And we have a build acceleration for faster incremental builds. For the IDE itself, the version 3 preview includes the spell checking, accessibility checks for XAML-based desktop applications, and many other updates that you can find behind the link on this very slide. And we have a new .NET Community Toolkit version 8.1. With the updated Community Toolkit, we implemented multiple community requests as well. One of the most frequent ones in the community was having custom attributes for observable property. We also introduced dedicated analyzers in the MVVM toolkit. Now, it is no longer limited to providing diagnostics for features used incorrectly, but it also shows recommendations to improve. Good evening, sir. It also shows recommendations to improve the code and avoid common errors. Nailed it. We also added some basic source generator optimizations. Once again, you can find all the details behind this link. But now, ladies and gentlemen, it is time to open the official .NET conference after party by introducing Torsten Stiller to all of you, who will be taking a couple of seconds more for his session.
Hey.
Thanks for coming.
Hey. Thanks, Thomas. I need one more minute, yeah? Give me just one more minute.
So, what are you up to? Sheesh.
Okay. A little bit of confusion today. Sorry, everyone. Okay, I will now jump to my own presentation. Welcome to my session about .NET Maui. And to be honest, I'm not really a .NET developer myself or a .NET Maui expert, but I've heard a lot of buzzing around .NET Maui and everyone is saying, oh, you should try that. And that's why I just give it a try. And actually, I really liked it a lot. And I will tell you a little bit about my experiences and also show you what I've built, a tiny stopwatch application. And yeah, let's talk a little bit about .NET Maui. So yeah, you probably know .NET, right? You can build almost anything with a unified platform. And yeah, we can write applications for cloud, web, desktop, mobile, gaming, IoT, AI. We will see later ML applications and a lot more. And there is a great tooling around that. You know probably Visual Studio, the family, Visual Studio Code, CLI, and all those old days are gone when .NET applications were only for Windows. Now we support Linux, Mac OS as well. You see that later. And the ecosystem is gigantic with GitHub support, for example, and so on. And yeah, client app development is more important than it ever was. We have 1 billion Windows 10 and 11 devices worldwide and 4 billion iPhones and Android devices. And of course, we want to build applications for that, and we want to build it as simple or yeah, as effective as possible. And we don't want to write applications for each kind of device, right? We want to build one code base, and then we want to run it on all those different kind of devices. And there are other yeah, alternatives to .NET Maui recently, and yeah, .NET Maui I think comes exactly to the right time because we can then use the power of .NET. And for example, if you're an experienced C# developer, then it's of course a lot easier to write applications in C# for all those kind of different devices. So, does someone know what Maui means?
Multi-architecture UI?
Multi. Yeah, actually, multi-platform app UI, but very close, that's right. Multi-architecture was being said here. And of course, the platform means the operating system, basically, right? The underlying layer, and we'll see that in a second, is the most productive way to develop native apps with a single code base that perform great on any consumer device. And we are not building kind of unified code base that runs on multiple devices, but we are also leveraging different possibilities of those platforms. We will see that in a later slide as well. So unified.NET, that means we leverage the power of .NET. I mentioned that already. We have one base class library, CLI support, SDK style projects, and so on. And we target multiple mobile, desktop, hybrid systems, whether it's Android, iOS, WinUI, Mac. I'm running my tiny Maui app later on my machine here as well. And yeah, so the productive development is very interesting because you now really have one single project in Visual Studio, for example, and that makes work a lot easier. So you don't need to add multiple projects. So, and then with Visual Studio, if you're working on that, you might miss some kind of visual editor for the UI part. And I was missing that when I started to work with that. But it soon turned out that the kind of layering, the grids you're using and so on, this becomes very intuitive, especially because we have XAML hot reload. So that means if you do a change in XAML file or even in the code width file, then you are being presented in the simulator of your Android device or the iPhone, whatever. You immediately see the difference, then the changes you make. So, and this is the overview of a solution. We will later start that in Visual Studio as well. So a basic setup. And here on the left-hand side, you see the platforms. There are multiple platforms defined. And that is only there because if you want to use several features of one or the other underlying platform, so for example, Siri Kit or something from Apple, then you can put it there. Or if you have several different fonts for the different kind of target devices, so you put it there, but the actual code itself is not separated under platforms. You will have that as one single code base. But here you can already see that is the basic app. If you start a .NET Maui project in Visual Studio, then it's looking like this, kind of Hello World application. And you can run this on Android, iOS, Mac, and Windows. So this is the high-level explanation, the .NET Maui architecture. So we have the shared code, then we write in C# and XAML files, and then it's being translated to native platform code, so to say. And of course, we want to take a deeper look how this actually looks. So we start with our application code, our Maui code, and we want to work with the target platform like iOS, Android. So, and then for the application code, we have, of course, the .NET runtime that is doing the kind of translation to the different .NET versions. So there is .NET Android and so on. But above that, we have the .NET base class library, and then there's already .NET Maui, so .NET for Android, .NET for iOS, and WinUI, and then we have the .NET Maui layer there below the app code. Yeah, and I was starting my session while telling you that a lot of people are saying, "Oh, this is crazy. This looks good. Try it out." And here you can see it. This is a chart of GitHub stars, and you see .NET Maui has almost as much as GitHub stars as .NET, or .NET Core. But you see that it's been within 2 years, maybe 3 years now. Chart is already half a year old, and it's still growing. And I can show you why, because you can really build beautiful UIs, but not only UIs. We'll see that later as well, because we can use the native capabilities of those target platforms. But yeah, it's really as beautiful as you can see here. Of course, it's not easy to write a nice looking UI, but it's possible. So native platform experience are the best experiences. Why? Of course, because all those different target device platforms, they offer kind of unique features, right? Android has different features than iOS and so on. And the good thing is, with .NET Maui, we have a kind of an abstraction layer so that you can use, for example, here, C# for iOS and .NET, NetKit, ZeriKit I mentioned earlier, and we can use C# base classes to interact or to use those kind of platform-specific features on top of the UI that you can build with .NET Maui. Here we see another slide for Android. So Bluetooth, whatever, all those different capabilities you can directly use in .NET Maui. So here we see one difference. So .NET for iOS is using ahead-of-time compilation, where .NET for Android is using just-in-time and ahead-of compilation. But here you can see also the flow. You write C# files, XAML files, and then you're using the .NET runtime, of course. In case of iOS, you use ahead-of-time compilation to produce an ARM, and then you can publish that to the App Store, for example. Kind of similar for Android. Now let's talk a little bit about the .NET Maui performance improvements, and maybe also to give you kind of a background on the history of .NET Maui. You probably have heard of Xamarin. So that was the first attempt. I mean, Xamarin exists already for quite some time. Then we had Xamarin Forms, and that .NET Maui is also using this kind of base foundation, and not that it only puts new features on top, but also a lot of performance improvements. You can see 53% faster than Xamarin Forms, which is really a lot. And also 51% faster rendering and faster scrolling. And maybe you remember the times, I think 2008 or something, when you were using an iPhone versus maybe an Android device, and then you remember that the scrolling was on Android not really smooth at that moment in time. And it's really important to give that user this kind of user experience, right? So otherwise they are not using your applications. So now let's focus a little bit shortly on the desktop, because you're not only writing native applications for mobile devices or tablets, well, also mobile devices, but also for the desktop, right? So you can also write different kind of applications, not only the same application, but use different target platform specific features. For example, here you see the context menu. I won't play the video now again, but if you right click on a Windows or on a Mac here, then you see, for example, the context menu. Right click, of course, is not supported on any mobile device at all. So you can write different handlers for that as well. So it only will be supported on different or certain target machines or systems. Same with tooltips, of course, we don't have that on a mobile device, right? Or it's looking different. Or, for example, if you want to use create a multi-window application, so you can easily start a new second window, and of course that is also not possible on the usual mobile devices, maybe on some fancy Surface Duo devices, but yeah. So what's in .NET Maui? I think I have to be a little bit faster because the other sessions will also start hopefully on time then. Here you see a lot of content. What I want to highlight here is the MVVM model. This, of course, model view model approach is of course supported out of the box. And what I also wanted to highlight is there are a lot of possibilities if you're using animation or graphics, smooth, changing UIs can build, and of course the community toolkit. Because with the community toolkit, there are certain features that the community thinks are worth to implement, and then they can start implementing them, and then some of them might become one regular .NET Maui member or will be merged to the main code base. Just look that up on GitHub. There are a lot of examples what you can do with the community toolkit. Let me quickly check something. So you cannot see my screen, but let me. Just wanted to check something. Hopefully, we will see that window back again. No, it's somewhere. Ah, there it is. Okay. So, so here you can see the community toolkit on GitHub. I just wanted to check whether this is working because I'm also going to show you my demo in a second. But okay, let me open the presentation again. Sorry for that small delay. It's not that easy to. Okay. So, of course, all these are kind of main features, right? So 44 views and so on. But there are a lot of new capabilities as well. So those kind of main features, they have evolved also from Submarine and Submarine Forms. But with these new capabilities, you see there are a lot of new things that are possible. I won't read through that list. But here on the right side, you also see the changes from Submarine. So in here we now see a couple of nice looking controls, of course, completely unconfigured or something. So this is just the default. So over 50 controls, layout and views. On the bottom, you see different kind of layouts, so grid layout, horizontal wrap layout, and a lot more. So just to give you an overview. So, and then what I told you earlier already, there are APIs beyond UI. You can use app action, like on the right side and the picture you see. You can use, for example, on a Mac OS or on Windows, kind of application context menus before opening the application, right? If you press on the taskbar with the right mouse button or something, then there are additional actions. You can do that. For example, you can use the clipboard, device sensors, file system, network notification, and more. So you see that it's not only about building great looking UIs. So here you see a geolocation example. That's pretty easy. If you have a cache location, then you can use the cache, otherwise get the real location. And so then we register the service, inject the service, and then you're ready to go. It's just not really a demo. But now let's come to my demo. What I wanted to show you first, and it's also part of the description for that session, is that we are going to set up Visual Studio. In my case, it's Visual Studio. But I have to drag it to the other screen. That might be a little bit hard. Or I can extend this screen. I will try this. Otherwise, it's hard for me to show you something, you know, because I cannot code there. But okay, that should also work. Okay, I will open that up. New instance. Okay. Okay. So you probably know that pop-up window. If you open Visual Studio, then you can choose a new or a new project, or you can open one. So now let's focus really on creating a new one. And so here this is recent, but on the left-hand side you can see the different categories, right? And if you go to multi-platform, that is new, but it's only available in newer Visual Studios. It's not there for a long time already. So I think 16.4 should be the version you're using. And then let's choose app and .NET Maui app, C#, of course, nothing else is available here. And we're going to continue. We use as a target framework, we use .NET 7, and we just create something, try whatever. And we are creating this. So as simple as that, it's just a normal, could be a WPF application or any kind of application. It all looks similar if you run that or start that on Visual Studio. So, and the good thing now, I have to scroll out a little bit again. So Visual Studio on a Mac is looking it's looking a bit different than on other operating system. Of course, Windows has a lot more features. But what's important here is I want to show you that we can, and probably I need to make that a little bigger again, so we can choose different simulators. And so what we can do, for example, is use the iPhone or an Android emulator. Depends on what you have installed on your machine. And of course, I can use my Mac as well. And then, so you see, this is already the main page. So there is only a single page with this nice purple Android there. And we are going to run that. So where's my mouse? Okay. So and here you can see you have this folder for different platforms, which I mentioned. If you want to place target platform specific content somewhere, then this is a place to put it to. And besides that, here you have the app XAML, which is kind of the main XAML, and then of the starting point, and then you have the main page. And of course, you can add a lot more pages here if you want. And this XAML.cs is the code with file. So here you have already a handler. So on counter clicked is doing something, so it's incrementing a count, and that should be enough for the demo application. So let's see. Oh, it's on the other one. So it has compiled everything. And here you can see nice. So this is because I'm on. Okay. Still this is okay. Okay, I have to go here and make this a little bit smaller, and then we have it somewhere in the background. So there it is finally. Okay, so it's only you know, the starting point, and of course it's working. But I can also show you how to implement a really tiny application, and we will use my stopwatch program. Okay, let me quickly jump back to the other one. So I'm closing. I'm closing the other one. So, okay. But you see, if you want to get started, it's really easy to get started with that and to play around. So now I'm dragging this over. Just wanted to show you how easy it is and how so that you don't need to write a lot of code to come up with something that is not only a UI, right? Let me make it a little bit bigger. So if you're here, you see I've added 2 fonts. So if the device is not having that as system fonts, then you can ship it with the application. And this is the whole logic of my tiny stopwatch application. And of course, maybe it's not the best habit to put that into the code whiz file, but you maybe want to use MVVM, for example, then you can hook all the data sources up to the actual XAML file. Right now, the XAML file, which is defining only the grid and some UI controls, is also very, very small. I'm using a grid, so with 6 rows, and yeah, let me just start that application so then you can see it. So where are we? Okay. Okay, I think I've started it already. Let's see where the emulator goes now on that multi-screen setup here. There it is. Great. Okay, you see, it's not the most beautiful UI, but that's not the purpose. Just wanted to show you how easy it is to write a little bit of application, and you can start and stop or use the lab functionality, right? So what a usual stopwatch app looks like. And of course, it's looking the same or almost the same on a different simulator. So if you're using, for example, the iPhone simulator, we can easily do that as well, or an iPad or whatever. And it's also very fast to start. Yeah, and then again, if you want to change something, so the color of a button or something, you don't need to recompile it or build it. It will be visible directly. Okay. So wait, this is more. That's still the Android device, right? Yeah, sorry for here. Okay, so it's looking exactly the same. I would say exactly the same, and now running on an iPhone here. Okay, let me switch back to my presentation. Was easy. Okay, so we built this. Well, we didn't build it, but we started it. And so as a starting point, this is super easy. And yeah, now let's talk a little bit about the product life cycle. If you want to develop, of course, test, build, distribute, monitor applications, then you can use the whole ecosystem of solutions that are available. Of course, you can use Visual Studio Code for building. Azure support is there as well, so you can use the App Center. So this is the App Center here. So you have their support for test, which has been, I think, is in beta since last week. So this is great because you can use it for testing, building, distributing, monitoring. And then you can push it to different app stores if you want. So let's see. And then there are some vendors who are creating even richer controls. Of course, you have to pay for that. But just to showcase how really nice looking UIs that have been built with .NET Maui can look like. So one last thing I wanted to mention here is that you can also bring native client capabilities built with .NET Maui to your web applications. And if you're building .NET web applications, then you're most probably using Blazor. It's also possible to use Blazor hybrid apps. So you can use .NET Maui, and on top you can use Blazor hybrid apps. So that means you not only write applications for or native applications for mobile devices, for example, but also for the web. And you can reuse UI components across both, and you embed controls and so on and a lot more. So as I told you, built on top of that .NET Maui platform, App UI. And you can still access the native APIs, which is also really cool. So native APIs of all the different target systems. And you can mix and match web and native UIs. Of course, you have to be careful, otherwise it looks a little bit ugly. But that's giving you a lot of additional power on top of that .NET Maui. So we have that shared business logic, and then we have that shared Blazor components, and everything you have to do, you can write everything in C# and SAML as well. So not only iOS, Android, macOS, Windows, but also Blazor apps. So if you don't know what to use, then if you want to reach a lot of people, then you're probably writing web applications, websites, PWAs, and so on with C#, HTML, CSS. That's the normal Blazor application. On the other side, there is .NET Maui, which you're writing C# with, SAML. And then in between, there is Blazor plus .NET Maui. And it's not that you're using both together. There is really, Blazor.NET Maui hybrid application on Visual Studio as well. So at the end of this talk, let's quickly check the future timeline. So every year there's a new .NET version, a new major version, and so .NET 8 will be available this year in November. And .NET Maui is an optional workload with external dependency, so such as Xcode, Android SDK. So if you want to develop .NET Maui applications on the Mac and you want to use it for, of course, macOS development and iOS development, then you have to install Xcode and Android SDK tools as well. And then you will receive patches for 6 months after each major release of .NET Maui. And Submarines SDKs will receive some support until May 2024. Hopefully everyone that is using Submarine will have migrated by then to .NET Maui. So at the end again, if you want to get started, then you can do that by going to .NET Maui, and of course you want to use Visual Studio. You can also use Visual Studio Code for .NET Maui, but it's a little bit harder to set it up. And the good thing is that you don't need Visual Studio Professional or something to get started. So you don't need to buy Visual Studio. You can also use a community version of Visual Studio if you want to play around with .NET Maui. And it's working there as well. So to save us a little bit of time, I think that's it for my session. And yeah, thank you for being here and listening to my session. And I hope that you really start to play around with .NET Maui, because it's really, really interesting and makes a lot of fun. And you see immediate results, right? Okay, with that, see you later. Thank you.
Do we actually have minutes for a break, like 5?
Yeah,
I'd say if any one of you needs to visit the back room, I would say we continue with the next session in 5 minutes. So feel free to grab a drink. There are some in the back. And after that, we will be having the OpenAI session, if I recall correctly.
Yeah.
Brilliant.
Hier nicht an die Zeit. Doch.
Dann ist das.
Warum kann man das denn jetzt nicht sehen eigentlich?
Ja, genau.
Let me see. I think I'll do that. Let's do the stream. Oh, I can do that. I see. Hey, can you hear me? Let me see something. Hold on. I'm going to go back to camera. Is my audio working? Just want to make sure that the audio is working. Audio is working. So can I start? We ready? Awesome. So thanks everybody for hosting me today in terms of something really exciting, really something that I've been super fascinated with in terms of the entire journey with OpenAI and some of the work that we've done in terms of integrating with the services in Azure and also across other products. And it's a super exciting time, I think, in terms of being able to use, I would say, real AI, proper AI, in terms of being able to enrich your applications with it. But there's some things that you're probably not doing right now as you start testing out things like ChatGPT. And I'm doing the same thing myself at home as I'm working with the tools and all of the various options that we have both inside and outside of Azure. So what I wanted to do today is actually show you the power of using basically few shot, zero shot, and one shot as part of your prompts, and also what tools are available today and some of the things that you can do with the OpenAI services in Azure and just in general, because there's a lot of power from a text as well as image generation as well as code generation that you can do to really speed up a lot of the workflows that you're working on now. Just a few words to me. Maybe you know me from Microsoft Mechanics. I actually started out als Informatiker in Deutschland. Ich habe da angefangen in IT zu arbeiten. I'll go back to English. Some of my best memories are in Germany, going to see my favorite football team, the Bavarian team in Munich, or as I might say, as I was there at the time, Minge. And riding on the Schönes Wochenende ticket with a bunch of strangers that I would collect on my way down. So I've got a long history in terms of living and working in Germany, and even after Germany, I worked with Bertelsmann in China afterwards doing IT. So wanted to go through, basically my background. And thank you for hosting me today in this conference and kind of the after party. All right, so let's get into it. So in terms of OpenAI and Azure and working with prompts, so the first thing you need to know about, I guess, is kind of what we're doing from a natural language and GPT perspective. So all of these different models that we're seeing are based on GPT, so they're generative models, and they're basically trying to distill the human language inputs that you're asking for it and what to do with it. And then basically with that, for example, we're using Codex to be able to generate code using kind of some of the models in the background, and DALL-E 2 to generate images based on a collection of images. And all of these things together, GPT-3, Codex, and DALL-E 2, are part of what's in Azure OpenAI right now. And you can create your own customized models. You've got the Azure OpenAI Studio that you can use with a playground. I'll show you that in a minute. But the nice thing is, because it's part of Azure, you have all of the Azure abilities behind it. So you have all the different security options, the controls that you would expect in terms of building enterprise-grade applications. So when you get started in terms of using Azure, you can basically go into the playground, use different deployments there. What you're doing is calling a web service. So this will work whether it's .NET, and I'll show a .NET example in a minute, or other ways of building your apps. You're calling that web service, sending information to it. And the nice thing is, because it's in Azure, you have things like the security around your data. You have private endpoints. You have the ability to do things like language filtering to make sure that your applications and what you build, what you write, is responsible. And part of the big concept here with Azure and with OpenAI is that we're really trying to really make sure that the usage of AI is done in a very responsible way. So that's a lot of the efforts is trying to build the best solutions, the best tools. So in terms of what the playground gives you in general and what you get from Azure, the nice thing is you can do things with generating kind of what we're seeing here is zero shot to have it answer certain questions. I love this one, restate how winter's coming. Well, it's getting colder. But just to give you an example in terms of what this is something called zero shot. Now, zero shot means you're basically asking it an open question. Now, when you do few shot or one shot, that means you're actually giving it an answer and kind of the output of what you'd like it to generate for. Now, this is probably something, again, that you might not be doing as you're using and testing with things like ChatGPT, for example, in some of the public spaces. And this is where you can basically distill down the type of answer, the length of answer that you want to see as part of it. So this gives you then more control in terms of A, being able to feed it the data that you want, and then B, being able to get the type of output that you want as you write and build your own apps. So the other things that you can do then with this then, and I'll show you a few examples in a minute. I've built a console app in .NET. We're going to show a few examples with some games and other things as well. But just to go through, this has been a longer journey from a Microsoft perspective. If you look at kind of the timelines that we have, we've been on this journey since 2016. You can see that we had our general availability just literally last Monday in terms of the Azure OpenAI service, and this is something that you can register for access to get access to it today. And I would encourage everyone to do that. And I'll have a link at the end in terms of how to get access to the service. So let me just go into a couple of different examples of what we're doing in product. So you've probably and potentially have seen OpenAI integration as part of GitHub Copilot, DALL-E 2, super exciting stuff in terms of image generation on demand. And also in the Power Platform, there are GPT-3 inclusions for things like writing Power Automate, writing Power BI commands, etc. Being able to do that, basically using natural language inputs as part of the process to really speed up your workflow. So here's something that's brand new, which is Microsoft Designer. Now, one of the cool things that you can do with Designer is if you've signed up for the preview of that and have this running, you basically can generate AI-based images. So here, for example, if you type what you want in, say, a grass field with trees, what I love is it actually gives you examples of things that are even more sophisticated than my grass field with trees, in the style of Fauvism, in the style of Sao Laita, in the style of José Seurat, and all these people. But it will do all of these things and basically apply those inputs to the image. So what you can see, okay. There we go. There we go. So then it will generate that image. It's generating it, actually not searching for, but actually generating the image, and you can apply different parameters into it. And this is basically the equivalent of seeding additional information, additional parameters to tell it what to do. So here are trees with cows as a cartoon, and then you can keep going and have you can have this as a blocky video game as well. And then once you do that, this might give you a few different outputs that you might be able to use for presentations or other things. A lot of this work kind of started as part of PowerPoint Designer, but then incorporating DALL-E 2 as part of the model. So then once you have the design that you want, now you've got this nice visual that you use in terms of just giving human-based commands, and it's generating all of these images for you automatically. And this is a simple example, but it'll make sense in a minute when I get to the next demonstration in terms of how you'd incorporate this as part of a game with some custom code. All right, so the cool part too with OpenAI is the contextual awareness and what's around it effectively, and this is what part of the power is with OpenAI, and that if it doesn't have access to the data itself, you can actually feed it the data set as part of your prompts. And in this case, I'm going to show you an example of using it with a game. So you might all know Minecraft, and Minecraft is a great game in the sense that A, it's customizable, and B, you can basically do a lot of kind of command line commands against it in the console itself. So with Minecraft, various commands are available to you, like, for example, summoning different objects, summoning different animals and creatures. If I run a help command here, you can see there are literally thousands of things to know about. So imagine, and I play Minecraft, and I know, my kids have played Minecraft throughout the years, memorizing all these commands. Now, just to point out a couple of them, so you can see that we have the ability to clone objects, we have the ability to summon, to summon various objects. And to remember all of those things, plus the object names themselves, is not a super easy task. So what you can do is basically use OpenAI as part of the delivery process to make that easier, and to be able to, if you want, make it powered by natural language. So let me go ahead and show you what that looks like in terms of Minecraft real quick. So here, using the command, we're actually going to use an add-in that we've built called conjure, and say make a cow. And so that's basically translating that command into /summon cow. And so if we do the same thing and we say make us a animal that goes moo, it actually is able to decipher the context of what that means, because even though in all of your list of available animals, there's nothing that references the word moo, in this case, we can effectively find what that is. And the same thing as building a wall that you want to do as part of playing the game. If you say build a transparent wall, even though, again, transparent isn't an adjective that's in any part of the Minecraft command structure, it knows that glass is transparent and will build you the wall with glass bricks. And probably the coolest thing, and this is why I've got into kind of the mechanics side of things and reverse engineering everything since I've been very young. All you have to do is literally say at the top, you can see this is our set of basically instructions that we're doing to generate. These are the prompts effectively that we're throwing into our custom code that's going back and calling basically the Azure OpenAI service in this case for our mod for Minecraft. And all we're saying is translate English requests into Minecraft commands. Super basic. And then giving it these few shot parameters. So build a 2x2 wall. You've got to give it some geospatial kind of conditions as part of that. Give me a sword. So make a tropical fish. Now, the make a tropical fish few shot parameter that we added to this is actually the thing that was able to make it translate, where I say, you make me an animal that goes moo, all I needed was that make a fish and that one summon command, and it used that to basically extrapolate the other commands for all the other creatures inside the game. So again, very, very little effort needed in terms of being able to define what you want as your output. So let me just show you another example. And this is actually the code for the for the Minecraft mod. In this case, it's Java. But the nice thing with this, you can also use OpenAI to generate code. So for example, you can see here that I have some code that's actually calling the web service, and here you can see the web service string that we have to call, but I don't have a response. So the nice thing is, even though I don't have a response, because we're using Copilot in this case, all we have to do is basically hit the tab key a few times and it's automatically generating the response. And you've maybe seen a demo similar to this, but the thing that's amazing is, regardless of kind of the context that you're in, it's aware of the language that you're programming in, and it's able to write, code for you on your behalf. And it's not always 100% perfect. There are things that you might do differently or stylistically differently. But in this case, it was a fully working set of code that it generated to give you the response. So I think this is also a pretty cool use in terms of being able to use it to automatically generate code. So will it write, though, a .NET app? Because we're in a .NET kind of after party here in the Reactor. So let's try that out. So I've actually used, in this case, ChatGPT, the public service that I'm guessing a lot of you are already using today, and asked it, or prompted it, I should say, write me a simple ChatGPT.NET console app without using the OpenAI SDK, where the prompt is asking the user to enter a prompt. And so here I've basically given it very human, kind of normal speech. I probably would have rewritten that sentence again if I had a second chance. And it's generated the code for me to build a console app in .NET using Visual Studio. So here it's saying I need the API key, which you do in this case, and you can get an API key from either the Azure OpenAI service or from OpenAI, the public website. And so basically you would copy this code in. One thing to note, and it actually did give me on a few runs, it's using the Newtonsoft JSON NuGet package that you'll need to add in to get it to work. Pretty standard stuff in that case. So basically now I've pasted in my code to build a console app. Now let's see if it will actually work and ask me for a prompt. And of course, once you've met all the prerequisites, got it working, debugged it, everything is working. So, again, very easy. You can just copy and paste your code. I won't enter a prompt here, but it will work in the same way as all of the other sites, the playgrounds that you can get to through OpenAI and through Azure OpenAI. So let's look at a practical application of what this also means in terms of augmenting your apps, things like search, being able to, again, use the prompts and use kind of the underlying data to be able to extract the results that you want. And that's where the power is, because not only are you getting kind of these generic responses, but you can fine tune the responses to exactly what you need. And it's all about just manipulating and kind of massaging the prompts that you're sending into the service as the data set effectively, and then giving it few shot, zero shot, or one shot type commands in order to get the output exactly how you want it. So let's have a look at an example here. So here we've got a basic search app. Now this search app is using cognitive search in Azure OpenAI. And let's say we want to look for renewable sources. We've got some data sets already loaded into this, some documents, unstructured. And if we do a search, it's going to find, it's going to actually point out and give us a sentence. Let me turn off my camera feed here. It's going to point out a sentence that EIA expects renewables for 22% of the US, and energy, the electricity generation in 2022. And if we do searches for where those different words are coming from, it's actually finding those across multiple different documents. So kind of like, as you built your Diplomarbeit or the papers that you wrote whilst in university, for example, you had to read through multiple documents, distill the data that you wanted from each document, from search, and then figure out and make your own thoughts. And this is kind of what it's doing here in terms of being able to kind of distill everything needed in order to generate, grammatically correct, great sentence, and also, be able to give you kind of the output that you wanted across these different data sets. Now, the secret to this is basically plugging in all of that information as part of the prompt. So everything that you're seeing here in terms of the different data sets and the different pieces are part of what you're going to plug in from an OpenAI standpoint in as part of the prompt. And then in terms of the few shot or one shot / zero shot, those are also additional parameters that you'll do in terms of getting the output that you want. So here you can see, if you just kind of reverse engineer the code, the services that we're calling, that we're actually going in and sending it the data that we want, the documents that we want, and then requesting the summary from OpenAI effectively. It's very, very simple, just a few lines of code to get all of this to work. It's not, in terms of effort, it's not something that in the past where you would have had to write, things like ML models or AI models yourself. All of this is just being called through a web service with additional kind of tweaks, parameters that you're adding to it in order to get the responses and outputs that you want. So trying to make it super easy to be able to get the benefits of AI in this case as you build out your apps. All right, so let's have a look at OpenAI and the experience in Azure. So what does Azure actually give you in terms of above and beyond, especially if you're using the public OpenAI service? Well, as I mentioned before, you have all the security. You have, if you're using data sets that are, you wouldn't want to send that to a public web service necessarily. You want things like private endpoints. You want all the identity controls around it. If you're using Azure Active Directory, for example, for authentication, those types of things are available to you within Azure. Plus, if you're using ChatGPT now in the public service, sometimes they're throttling the service, turning it down. You have all the SLAs and all of those types of things as part of the Azure service as well. Plus, you have the ability, it's fully supported. You have the ability to experiment and build all of your own projects. You can customize models, all of those things in there. So let's have a look at some of the things that you can do in the context of Azure. So once you sign up for the service, you'll have, this is the Azure OpenAI Studio. And basically, all of these are examples that you can use for prompt completion. So here, when you go and look at your deployments, the deployments give you the ability to select the different models that you want, and you can name it. I've got a couple of deployments here for Codex and DaVinci that are already set up. So in my case, I've got kind of the base pieces to start experimenting. And so once I do that, I can go into to my different deployments and I can actually try some things out. So here I'm going to go into experimentation in the playground, and you can see, because I've got a couple of deployments already configured, what I can do is select the deployment that I want. In this case, I'll use DaVinci 2. And here, we give you some examples that you can use as well. So you can use examples, for example, to generate product name. This is the fun one with a milkshake maker. But if you wanted to say generate a name for a pair of shoes, here it gives you kind of what that looks like. And because we're using, in this case, OneShot to give the product name examples, the home shaker, fit shaker, it's actually giving us the product name examples that are kind of the right character count as part of that. So this gives you the ability to start playing with, how to use this. If you've ever gone through any naming exercises in software, and I think probably a lot of you have, it's one of the harder things that we do at Microsoft in terms of naming products as well. And so this gives you, some pretty powerful stuff that I would say that we could benefit from even ourselves. We name a lot of the services and products at Microsoft. This is actually pretty good stuff. So if we look at from a text summary perspective, so we just saw the example in the search and how that works. Now here is an example for, basically summarizing what the neutron star is. And so when we run this, it will give us an output where it's basically taking the text that's part of that initial prompt, and it's distilling down the facts for it to give us something that's about a third of the length in terms of text to summarize that out. And this is also super powerful in terms of being able to distill the information that you need. But of course, it gets even better than this. So, beyond, this example, what you can also do is, have it do things like yes, no questions, or give you even shorter answers if you want to. So from a coding perspective, it's very easy to bring in the data that you want. You can, here we've got our crossdock kind of data set that we're kind of pulling in. You can see this is a pretty big, long piece of data that we're going to pull in this case. And if we want to answer questions from that, we certainly can. These are the questions and answers, again, as part of FewShot in this case, to be able to have the prompts to give it the right outputs, or to request the right outputs, just to make it so you can see everything. We'll put in a shorter bit of text in the clipboard, and ask it to answer some key facts and make some key statements for us. So here, if we put the question of the percentage of homes with solar in top regions, it's distilled that information from the statements that are part of that prompt, and it's basically distilled the answer that we want. But let's say we want to actually make that even more concise. So this is where the power of giving it those additional few shot and zero shot parameters come in. So let's say now we're going to give it some additional information. We've basically got the same type of data that's in there, but our answer, we want it shortened like the answer that you see there. So now if I generate the answer, you can see, geez, my name tag's covering it up, but you can see it's much shorter than the answer that we had previously. Instead of writing a whole sentence, all we wanted was the percentage in the Northeast and the percentage in the other region, and now it's basically concatenated, made a more summarized and more concise sentence out of it. So again, showing the power that the prompt gives you in terms of really honing in, polishing the output. Let me see if I can do this apply. I'll edit my name here real quick. And you can see the output. There we go. 8.9% in the West and 4.7 in the Northeast. All right, so these are all the things that you can do then basically from an Azure OpenAI perspective. Now, we're going to be releasing ChatGPT functionality in the Azure OpenAI suite of services. We just announced on GA on Monday that you can sign up for it. In order to sign up, go to aka.ms/OAI/access, and that will give you access to the Azure services around OpenAI, and you can build your own studio environment to be able to start playing with and using the different models like I showed today. So hopefully this is helpful, and let me know if you've got any questions, and yeah, have fun. Just build some amazing solutions. It's really up to you in terms of taking it to the next step and using our OpenAI services, and keep using ChatGPT and all of those things and just experience it. Because I think the one thing I've learned is, as the GPT generations have evolved, even as DALL-E generations have evolved, it's just getting so much better pretty much with each and every release and update. So something that you can try now. And hopefully this, in terms of prompting and kind of what to remember the parameters and the prompts that you're sending through to those AI commands are really going to kind of determine the outputs that you're going to generate from that. All right. So again, thank you everybody for giving me the time today, and just start using Azure OpenAI, sign up for the service, and let us know what you think. And if you've got any questions, you can find me on social pretty much at Deploy Jeremy. I'm on TikTok. I'm on Twitter, LinkedIn. I even have a personal YouTube channel that you can find me for any questions that you might have. And thank you for letting me present with you and join you today.
den Sound etwas zu verbessern?
No, I just wanted to make sure that you are here. as well.
Okay.
So you should be
Hearable.
Hörst du mich?
Oder hört man mich jetzt doppel?
Aber wenn es gleich noch so geliefert sind, dann mal jetzt Slide, können wir ja. Das wäre praktisch.
Also fix that slide.
Wenn das Shifting weitergehen wird.
Aber hier nicht. Aber da nicht. Warum nicht? Das liegt aber an deinem Setup hier. So, hat mit StreamYard nichts zu tun. Kannst du dann hier einfach drauf gucken oder brauchst du Notes?
Ich brauche keine Notes. Aber,
Ach, du meinst hier, ja.
Also gehen wir wieder Duplicate des Displays, dann ist es vielleicht einfacher.
Oder wir ziehen das hier raus und ich mache es hier einfach rein.
Mir ist das völlig egal.
Ja, machen wir es so. Okay?
Ja. Aber jetzt dürfte ich die Slides wechseln können.
Ja, das kannst du hier dann auch machen, wenn du willst.
Hier kann ich draufdrücken, weißt du?
Mm.
Das Ding kann Touch im Gegensatz zu dem Max. Das ist sehr laut.
So, jetzt mal gucken. Wie haben wir das gemacht? So haben wir es schon gemacht, aber. Jetzt bin ich total verwirrt.
Du musst den 1 nehmen.
Ja, wir wollten eigentlich gar nicht. Okay. Now everything should be fine. You tell me when it should continue this talk.
Ich habe da auf Twitch rausgekippt, also das Team das noch da.
Twitch, okay. Weil?
Weil das so S-Team die Twitch-Konferenz ist jetzt für was anderes. Da haben Leute eben keine Zuschauer auf Twitch. Deswegen das nicht so schön.
I guess so. Jetzt schauen wir mal, ob ich da auch weiter switchen kann jetzt. Ich bin impressed.
Absoluten Trivium.
Unbelievable audio and video setup. So if you have the chance to come to an MTC, the experience is quite different. Yeah, and there's another challenge which would be interesting to be solved, the freight and traffic optimization. So 18% of the CO2 consumption or production comes from CO2 emission from the traffic, and would be interesting to reduce that to a minimum. And the problem on this is that optimizing fleet management is really complex. So maybe you know this example of the traveler for companies or for different hotel guides. So you have to visit or pick up people. What is the most efficient way to do that? Don't know why it's open now on other screen. Good. Still there. And we have also constraints like vehicle capacity, delivery time windows, cargo requirements. It would be easy to find a way, but you have to optimize the way with the cargo, with all this stuff. So this is quite complex, and current computers cannot solve that problem in a time which is suitable for everybody. You can do, but you need an Azure data center to calculate. Maybe it's a little bit too big for normal customers. I think it's quite expensive for optimizer route. And then we have another example which is really interesting, the MRI pulse sequence optimization, which means you go to a doctor and make an MRI, and the software can use this technology to find diseases, to find cancer or whatever in the pictures. The data is so much that current KI and AI things are not running fast enough to find such stuff. And quantum computing is expected to solve such problems. Especially the quality of the produced pictures is the huge impediment. So we have here a little scale how all this works. So we have here on the screen a crossover size. This is the problem which classical computing is not solving anymore. You cannot see my mouse. Maybe I can show it there. Here's this point where quantum computing can resolve problems which classical computing can solve, but the calculation time is not in a proper place for solving such problems. And you see, quantum computing has a very low crossover time to calculate that, or calculation time for calculate that problems, and other services cannot. So classical computing, and you see the top time is the age of the universe. Some problems really need time up to this value to calculate that. That's in cryptography. It's really often the problem that when the key is longer, you cannot calculate them anymore with classical computing. But the quantum computer can calculate the 2048 AES key in 1 second, really without problems. And Richard Feynman said, nature seems to be able to efficient and simulate itself. So since nature is quantum, maybe we have to use quantum mechanics in our computers. And it's not that easy as he said, but he is right, I think. So the difference between classical computing is you have a state transformation easily. So you see there, and that's the problem because we don't use PowerPoint, that we see all, that you have here the 3 states. One is disabled and 2 are enabled, and you have a transformation to, if you calculate one thing, to another value. the problem or the point in quantum computing is you initialize this quant or superposition quants, and with a quantum gate, you can transform that to a value which is mostly expected to that what you want. And it's open. You see there's one bulb which is not really yellow, and the other is a little bit more yellow, and one is dark. And that shows the value of a quantum. That means a quantum can be 1 or 0 or something between. Classic bits are always 1 or 2 or 0. And in the momentum I measure quantums, I get a value, a hard, fixed value, which is not possible to change. So quantum, in the moment you measure it, you destroy the quantums. That's like in physics. That's always the problem. You can measure it, then you get the value, and you can work with that. Then you have no value at the moment, only until you measure it. So you cannot measure in the step between. Something went wrong. Yeah. I get here StreamYard. Something went wrong. You're disconnected. Now I lost my internet connection.
That might be the reason.
But I should have one.
My work's still running.
Yeah, mine as well.
Why do we need this one?
I can change because there's no core network. Nobody gives me a Wi-Fi.
Yeah, no.
So I need that. Sorry. Hast du für mich noch wieder?
Also
Ja, dann nehmen wir. Ich würde einfach nur die Slides gehen weitermachen.
Ja.
Die zwei für das Kennwort verwenden.
Ja, lässt es passen?
Ja, We Love Linux.
Dann mach einfach nur.
Aber die Pizza ist gut, oder?
Hopefully. So, let's try again. I'm really sorry about that. But
There we go.
So, but the slides are not there. There are my slides. So it looks good. Better than expected. So, yeah, and that's a little bit a problem when PowerPoint is not in place. You see there a blue way to solve the labyrinth. And you see there are some red ways which are not successful. Usually when you use the classic approach, you do every try in serial. The quantum approaches, I try everything in parallel. I try every approach which I can do in parallel. That means the big advantage of quantum computing, you do calculations, every possible calculation in one step. So you have no serial calculation process. That's the biggest advantage on quantum computing. All stuff is calculated in one time. The disadvantage is you have to find the right value or the right way to use. So this means you do superpositioning calculation, which means that you put all your results together, and the result which has the most often occurrence, yes, should be the right one. So that's also the problem why you need more than one qubit to resolve a logical qubit. So you need more physical qubits to resolve a logical qubit. But the interesting stuff is how many classical bits can a 64 CPU process in one step? It's usually 64. Well, a quantum computer with 64 qubits can process in one step 18.4 billion bits in one step. So can you imagine how fast you can calculate stuff with such ideas? It's quite fast. So a good example is, like I said before, the AES encryption. To break it or to calculate an AES encryption key, usually you need at the moment something about 200 years. This 2048 bit encryption. A quantum computer needs less than a second. And that's really quite fast. And there are some use case categories for quantum computing. So you have optimization use cases, you have simulation use cases, you have dynamic system use cases, and you have cryptography use cases. So there's, Peter Shor said in the past that there must be a new way to encrypt. And there are post-quantum processing algorithms, how to encrypt safe that quantum computing cannot calculate the secrets. There are some points for optimization. So you have quantum machine learning and optimization methods for optimization, and mostly is really resource optimization, what you get out of that. But on the simulation, it's often so that you can find their molecules and chemical reasons. I know that BioNTech use sometimes quantum computing to find the right molecules for their problems. As well as to have a prediction of material characteristics you can calculate with quantum computing. Much more faster than you can with the current computers. Then you have some dynamic systems like weather, fluid simulation, all this with the dynamic systems. And one point is also encrypted communication, which is really interesting, especially for military purposes and for much other stuff, like in banking, you want quite heavily encrypted communication. So then let's have a look on that, how many quantum qubits we need. So for material science simulations, we need above 1 million. It's 1,000. It's not 1,000, it's 1 million qubits. For chemistry simulations as well. But for science and the scientific understanding, we can start with 100,000, which is quite, as well, quite many. The problem is not that you need so much for the logical process. Logically, you need maybe 6,400, but to get one logical qubit, you need approximately 10,000 physical qubits. So that's why this number is so high. You need so much physical qubits to get a strong result. And here we have a small development roadmap where we are at the moment. That's not from Microsoft, that's IBM, Quantum. And we are at the moment in the year 2023. The Condor chip is on site at the moment. It's 1,201 qubits. So we are quite near on the first 1,000. And the interesting stuff is how is this physically built? So we have there now new quantum computers which are not completely entangled. So they use 3 units of 133 qubit units. And that it's quite helpful because if you use or need 10,000 qubits to make one logic, it would be easy if you have 10,000 of this Heron 133 qubit processors. Then you can get a strong result on that. And they work on that with some quantum bridges, so physical quantum gates. And they hope that 2025 they have a quantum parallelization for multi-chip quantum processors. So they can get 4,000 qubits. So the next years will be very, very interesting on that. But you want to try that, or? And that's possible. You can try quantum computing at the moment. And we have there an offering which is called Azure Quantum. And you have there use possibilities with code. So you have Q-Sharp, you have Circ, you have Qiskit, you have Python Quantum as well. And we have many, many different hardware systems, Ionic, Pascal, Quantinuum, Rigetti. That's producer of quantum computers. And you can select in your Azure Quantum which you want to try. Some are simulators, some are demos, some are real. So you have real quantum computers in Azure, which you can use. And you can completely integrate and scale with Azure. So you can use GitHub, you can use Azure DevOps for that. So that's the usual Azure Quantum architecture. So you write it on your Jupyter notebook, or you write it with VS Code. You can also write it in command line, because you can also put there some quantum assembler code if you want. And then you create with that a quantum job. And this will put in a, first in a storage account, and then you put that as a translated job in our quantum systems on Azure. And then when the job is on its place, you can calculate, it will be automatically calculated when you get an event and the result back on your Azure. So we, as I said, there's the universal gate-based quantum computing, and we have also a quantum-inspired optimization. In the past, somebody thought, hey, we can use quantum computing, or we do on quantum computing calculation. But the other way is we can quantum-inspired hardware. So we can build hardware which quietly is like a quantum computer. It behaves like a quantum computer, and it's quite faster as a regular computer. So you can try that, and it's not the full functionality, but mostly it helps to obtain and optimize stuff. So if you want, there's a possibility. So you can run algorithms in quantum computing and use that. That's code. I think it looks quite familiar to you. So you have here the open quantum intrinsic measurement in Canon, and then you use a qubit, you have to initialize it, then you have to put it in a superposition, which is an initialization of the qubit, that it can be used. And then you have the measuring method for that. So the M is measuring and the H is the superpositioning of the quantum. That works quite well also with arrays and lists. So you can use that as like an object. And usually you have, when you make some minima or maxima calculation, you always have a not great minima, or you have better minima, but you want always to find the best one, or when you make such calculations. And with a quantum optimizer, you can find with quantum tunneling the best value, because it's possible to find there with the terminal jump, because you calculate so many results at one moment. You can find easily such stuff, which a regular computer cannot do. You have questions on that? It's hardcore stuff, huh? And the same point is, so you can calculate optimizations of landscapes for when you build something, you can do their optimization, how to bring fertilizers there and all that stuff. And that is possible with quantum computing. So I hope we have some practical use of quantum computing. So you have a business problem, you create the algorithm, and then you put it to the Azure Quantum Workspace, and then you get the result. Usually it looks like that, if you want to use that. So you have, and that's the point, usually you will not get rid of the current hardware in the future. You will have a normal computer, because nobody will want to put a quantum computer at home. You know how big a quantum computer at the moment is? So the quantum computer maybe is like a 19-inch rack at the moment. The cooling for it is bigger than this room. Because at the moment, the hardware has to be cooled nearby 3 Kelvin to work. So the computer is quite small, but the cooling is the big problem at the moment. And you see that you have a function app which makes the job submission. You have a function app which delivers the status and all that stuff. You get back and deliver then as a normal application to the customer on the customer facing. So it's easy to implement and to build quantum stuff. Only the backend service which calculates that is in quantum. The rest can be in quite open services like Maui. Yes. So DevOps with quantum computing is also quite like that. And you have here the inner loop and more stuff with writing code, unit testing, and run on a QDK emulator. You can test your code. And you have some simulators. I go straight through because I think Alex is directly after me, or?
Yeah, sure.
And I have there something for you, getting started. We are from here to in the next 5 years, the quantum table is more so that we say use case focused into cross between quantum and high performance conventional computing. We can solve some business problems. We can, the stakeholders align themselves to the ecosystem, and we prepare to impact disruptive technology. And post-quantum cryptography must be ready. Because after 5 years, there will be a significant global private and public investment into quantum, especially military. And we have complex industrial use cases unlocked. So in 5 years, I think we can start, after 5 years, we can start with quite industrial and complex problems to solve with that. And if you want, you can have an Azure free account. You get Azure quantum credits for every quantum provider in a workspace. You get $500 credit. So you can have, if you build an app in Azure Quantum, you get 10,000 from Microsoft for that.
Credit.
Cash.
Really?
Yeah, they pay out that.
I have to leave.
And I have here some resources. I provide you with the slides later, and then you can get that. And there is something in place. So we have here some cases. You can have a look on that. The aka.ms at ag-cvru is the case Western Reserve University. They made four times faster scans on MRI, so they have a 50% better image precision. And Trimble made a freight optimization with transport and logistics that improved the supply chain and reduced emissions. The values I showed you before are true. They did that. But for you, why not do the energy efficiency in agriculture? It's a challenge, huh? Hopefully challenge accepted. So thank you for your time, and hopefully it was some impressive stuff which you never heard before.
Yeah, thank you, Christian. Let's see. Next episode of
Technical improvements.
Yeah.
There's definitely not this for pizza. The guys should grab a pizza.
Yeah. Then tell them, or I can do that.
Yeah.
Let's read. Wie machen wir das? Hast du?
Ich habe, was ist das, HDMI? Habe ich. Kriegst du nicht.
Bist du in Stream?
Nein. Achso, ich habe den Link
Jeremy hat dir geschickt, ja.
Ja, das kann ich aufrufen.
So, die Bilder angezeigt sind, wollen wir gleich das noch übrigen?
Bitte?
Wollen wir gleich die Präsentation von dem Surface-Ding zu
Okay.
Achso, genau. Ich schicke Alex den Link.
Ich habe den schon. Achso, dafür muss ich online sein. Da bräuchte ich kurz dann Internet. Sorry.
Kimburg Guest.
Das ist geil.
Guest, genau.
Jawohl.
We love Linux. Billiges Virtue Signaling.
Ist egal. Hauptsache ich bin online.
Ja.
Weil der Torsten hat mir das schon zugeschickt.
Ja.
Wenn ich ihn finde. Na komm, da. Session. Da ist der Link. Na komm schon. Ja. Das will ich nicht aufmachen. Kann nicht sein. Echt jetzt? Die E-Mail macht er auch, aber die macht er nicht auf. Okay, dann machen wir was anderes. Doch jetzt. Endlich. So. Genau. Zugriff auf Mikrokamera zulassen, jawohl.
So, und jetzt brauche ich einmal dein Tägelchen, das ist sehr schön.
Ja, ich mach mal so. Alex Wachtel, kriegen Sie mich auch alle. So, und Studio weiterlegen oder beziehungsweise hier noch was machen?
Nee, erstmal genauso lassen. Ich kann mal das alles in den
Okay, hier vorne, ja.
Genau. Und jetzt brauche ich von dir letzten Endes einfach nur, dass du deine Themen einmal hinzufügst und eine Präsentation, genau. Ja, dann kannst du Bildschirm teilnehmen.
Bildschirm teilen.
Sie.
Bildschirm teilen. Da sagt er jetzt was.
Ja, welchen davon?
Nee, Conf ist der gesamte Fenster. Das sollen wir den gesamten Bildschirm verteilen, oder? Das ist am einfachsten. Audio-Systemstyle rein, oder so?
Ja, dann können wir das Audio nämlich über deinen nehmen. Bin ich ganz zufrieden.
Aber irgendwie will er das nicht, doch jetzt.
Genau.
So,
Das ist wirklich Profis, ja, genau.
jetzt mache ich das mal weg.
Gute Idee.
Verstanden, ja. Und jetzt machen wir mal kurz hier vorne mal.
Muss ich jetzt hinzufügen?
Natürlich. Dankeschön. Nö. Bei irgendjemand muss es noch funktionieren. Wobei das später funktioniert. Ja, bis jetzt hat funktioniert. Ja, das ist ja gerade gefragt, ob das auch aber aktuell funktioniert.
Audio funktioniert. Muss dann nur gucken.
Last but not least, oder?
Naja, bei dir geht es jetzt recht fix eigentlich.
Ja.
Der hat da jetzt eine Holzaufsteller mit ich.
Der hat jetzt nicht gedruckt. Den 3D-Drucker.
Sammeln. Amazing.
Ja, ich bin auch begeistert.
Ja, wir müssen dann nur schauen, dass dein Gesicht irgendwie im sinnvollen Bildausschnitt ist und dann kannst du theoretisch anfangen.
MTC. Da gibt es einen 3D-Drucker. If you like, you can still grab a pizza or drinks. Just get another beer. Another beer. For you, especially for you. I got to at lunchtime. Do you want to make a video or picture?
Only picture.
Yeah, only picture, okay. I thought you were waiting for me to start talking. Okay. No, that's no problem. There's nothing private here. Ja. Ja. Das heißt, ich muss hier stehen?
Ja, wenn du ein bisschen sichtbar wärst, das ist gut.
Ja, genau.
Perfekt, gut.
Dankeschön. I've been here in November and we could walk everywhere here. But this time, yes, and this from this camp, and this time I have to stand here. So guys, because of time, I'm 5 minutes late on time, but I think it's okay for us. Welcome to the last session. That will be about .NET applications and also ML.NET and about machine learning. So what's that? .NET and machine learning? Never heard about this. I'm CEO and solution architect from Karlsruhe at the EC Germany. That's my working address. We are Microsoft Gold Partner or Legacy Gold Partner since it's now Legacy. 10 categories we have been awarded that, and my background is I started as an MCT from Microsoft Certified Trainer several years ago with Windows Server, Exchange, and so on. So on-premise systems, moved somewhere in the cloud to Microsoft 365, so Exchange Online, Azure, Active Directory, and so on. But at this point, I also started my PhD after computer science, studied at KIT in Karlsruhe, and that's why I'm now Microsoft MVP, because I have done a lot of stuff and also tried a lot of stuff, perhaps. And I don't share any slides here. I'm sorry. Yeah. Thank you for your time. That's it. No, there should be a second slide. I'm sorry for that. I'm sharing. Oh God, not this time. Oh God, and I'm always getting.
Looks better, right?
It's a little bit, but this is internal. Yeah, thank you very much. Cool. I'm sorry for that. So yeah, the whole introduction one more time in short. Alex, my name, and I'm Microsoft MVP, also MCT, and the whole bunch of certificates. You can just look it up. It's all on the Microsoft 365 expert, Azure Solution Architect, DevOps engineer, also cybersecurity architect, and also something from AI. And my first question to the audience: are you on the right side or on the left? You understand this? Are you on the right or on the left? Who of you is Python developer? One. Okay. That's a half. Okay. Cool. And who of you is or tried .NET? Okay, with machine learning. Okay, only .NET. It was also sometimes or half from an audience, but .NET with machine learning was nobody. Cool. Okay. That's why I'm switching to no, not this one. Sorry. I prepared both, also for .NET and also for Python people, because if you are going to select Python, you will find a lot of tutorials, a lot of samples on the internet, and so on, and they are all in Python, I think. And you can start easily. The first, have you ever tried Visual Studio? I think so. Yeah, Visual Studio Code is cross-platform tool, but Visual Studio is it's a developer tool since a lot of years, and you can just click on your solution if you install also machine learning, and also just add machine learning to your solution. Then you will get ML.NET Model Builder there, and pick up a scenario in the first step. In the second step, pick up your data. So you will see there's a lot of several steps that are similar to Python. That's already the same. You need SDK, you need libraries. because you are not running machine learning without libraries for machine learning. I think that is quite simple on this one. You need data. I think this is the biggest problem, to get data today that are good enough, good quality, and so on. And okay, after this, if I select data, I train this, I evaluate, and then I get some code. That's the cool stuff of this, is I get also code how to use my trained model. So in this case, I just train it on my local machine. I think that's okay for the beginning, but you will not start training a lot of data on your local machine. Yeah, it's not state of the art how to use it, but you see this ML.NET model builder, you get it for free. And it's really cool because I also prepared some kind of, you can see a screenshot for this, but I'm prepared if something not work, I just go there and get you a screenshot for this. So I don't need to be online with my machine. So I was prepared for this, that is offline. So if you compare these, so to how to use this kind of machine learning in .NET, first of all, okay, using, you need some libraries, so Microsoft ML, Microsoft ML Data, and so on. Then, and you see this a lot of time, you need to initialize a ML context. So you get there and said, okay, I need one ML context. You see that at the line 8. After this, you can choose if you want to fall back to CPU. Do you want to use only GPU? In this case, you can go there and get some logging initialized. But the whole idea is here, perhaps you need some columns. So you initialize your variable columns as your new array, that these kind of columns from your data. You get some data inside, so you can load, for example, if you have a lot of rows there, you want only 1,000, you can also specify this. And then you load your data. So similar as in Python also, so that's okay. You split your data, so 0.2. So if you're trying to get to machine learning, you will see this a lot of times. So 80-20% splitting the data, that is okay for decent. You can also hope you split the data as the same. 80-20? No, why? What kind of data splitting are you using? 70-20. Okay. Why? Okay, that's cool. In this point, you'd use 70 for training, 20 for testing, and also 10 for evaluate.
70 for training, 20 for validation, 10 for testing.
10 for testing. Okay, sorry, I just split it a little bit. The next one. If you go there, the next is pipeline. So you have to do some, you get your pipeline done, you train your model in this pipeline, that's okay. Then you predict, you transform this. So that the next step, you evaluate this. You will see that is the same as also in Python. You save your model. Okay, if you save it to a zip file, perhaps that is a little bit not so cool, but I think, okay, for this time, for this kind of example, I think it's okay. And then you can go there and just evaluate this. And after this, you can use it. So if you are going to Azure Machine Learning, so that is my point of view, I don't want to use this perhaps locally. I don't want to train locally, because if you have some kind of data that can be trained locally, that is not really big data, that is not really big enough to blow your computer away. I think if you run data science on your computer, perhaps you have some computes, just something like this, like GPUs and so on. Perhaps you have a great computer stuff and so on. So If you go to Azure Machine Learning, you have to create your Azure Machine Learning workspace. That is the first one. After this, I'm online. Then I can also show you if you want it also live. So because I have to join this machine to the streaming. Then you can create compute instances. I have created one GPU, one CPU, and I didn't remember how much do they bring there. One moment, I'm sorry. I can go there and just select GPU and show some details. So we have 2 GPUs and we have a lot of some information there. So if I'm going here to my notebooks, for example, and also select one, you will see here I'm online and I'm also using now Python. That's okay, yeah, on this point. If I'm going to search for now, the CPU is the 8 cores and 56 gigabyte RAM, and GPU is 12 cores, 2 GPUs, and 112 gigabyte of RAM. So a little bit more than this surface, because I have only 8 gigabyte of RAM on this surface, and it's only for presenting. So I would never do machine learning on this machine. So perhaps if I want to get this, to kill this machine, or perhaps, but in production, never. So if we are going to switch back to the slides, sorry for that. That is not the right one, this one. I can go there and create some compute. After this, if you want to try this, I wanted to try exactly this scenario in Visual Studio Code on this computer. So I connected to my GPU resource on Azure Machine Learning from Visual Studio Code. That's really cool, I think, because I don't need to run Visual Studio in this case on this machine, because never try this at home because you need more power for Visual Studio. 8 gigabytes of surface, it's not enough power for Visual Studio, in my opinion, for my project that I have done. So if you are connecting from Visual Studio Code to your Azure Machine Learning instances, you have to trust, of course, these folders from the input. If you are there, you see this is the same. This is Azure Machine Learning from a user connected to Azure Machine Learning GPU. That is all of the resources there. And then I can start also create here also in .NET, also in Python. I don't care which kind of language to use specifically. You can write in both languages, that's okay. You create your code here and just push it to GPU and run this there. So that is a cool idea on this. Of course, if you are there and you want to run something, you need to install some libraries. If you can do this with install Azure AI ML, this is not particularly installed in your Visual Studio Code. You need C# extension for this. And in this kind, you have to look after this one. You see here that I am using here Azure Machine Learning. I'm sorry, my mouse struggled a little bit. Azure Machine Learning. This is extension you can install directly in your compute. So Azure Machine Learning GPU, you connect to your compute instance and just install all of this stuff directly in this instance. Not only local, you can also disconnect from this instance and install all of the extension also locally. But if you, perhaps it's okay to install, for example, Git extension or some other extensions. But if you want to run to machine learning components, you have to do it in perhaps another instance. So you can also install, and it is really cool, this ML.NET model builder. That's unfortunately in preview. So that's if you want to try this, you should not try preview products in production. Yeah, that's great. But if you are clear on these, you can just go there and install this in your Visual Studio Code. So you don't need Visual Studio to use ML.NET Model Builder. So to run this first example that I have shown to you. And the cool idea on this is that I can go there and just switch to Visual Studio Code. And I'm online. That is the cool on this, because ML extension, I don't want to go there. Also, this is the code that I have just prepared to show you how does it works. And then if you want to use your Azure Machine Learning, you of course install extension Azure Machine Learning. After this, you can connect to your subscription. So you should already have created your Azure Machine Learning workspace. So you go to your Azure portal and just create. I can also show it up if you like. If I'm going here, portalazure.com, and I just run this. Sorry for this, but you see this the whole time. So you should create this kind of Azure Machine Learning workspace. So this is a component in Azure. And if you created this, you can go there and use it as a portal. You need for this, okay, application insight is just for logging, Key Vault, and storage account for logs. Yeah, you create only three components for this. If you go there on Azure ML Workspace, you just launch this studio that I have already launched here, and then here we go. You can provide your data inside from Azure Machine Learning, so you get your data sets from everywhere. You can define your jobs. In this tenant, I haven't done this because I have to build it in another one. And after the job is done, you can provide pipelines, and also you have your models and also your endpoints. And if you create endpoints, you can use these models that have been created inside Azure Machine Learning. So in this at this point, I think it's clear that I wanted to go to here and just compute. You see here that I'm not connected to nothing. And if I select just, I want to right-click and connect to my instance, you will see that here now I'm installing Visual Studio Code, I'm installing Azure ML WebSocket, and I'm also now connected to Azure ML GPU. So I'm now inside of, oopsala, get the SDK. There's one SDK missing, who cares? I'm inside from, come on. I'm now in the cloud. That's a cool idea how to use it. So I wanted to break my surface, not to use machine learning components on locally. So just go there and just now you see here I'm connected to Azure ML GPU, and if you now run extensions, so whatever extension you like, what kind of extension, Docker, for example. I go to Docker, you see here that I can install this kind of extension directly in this GPU. So you don't care after this about your local machine, and I think that's really cool. I don't want to install all of this stuff for machine learning if I want to use .NET or Python. Both from it's exactly how to use it. Just go to the cloud, install all of the perhaps extension you like, or perhaps what kind of extension do you create it or installed for your machine learning project? What do you have there? So besides Python and Azure Machine Learning, AI and so on. Okay. If you want to install this, you can see you need only subscription. As we have heard from Christian, you get subscriptions for free. So you can try also quantum computer, or you can try also Azure. You get subscription for free. Install their Azure, connect them, and if you want to use, of course, Visual Studio Communities for free. But it's a little bit, it's simple to install, of course, but it needs a lot of resources. Visual Studio Code is a cross-platform. Then support the extensions in the cloud to your compute, and then go on. And that is really buying for free because you get your credits for 1 month earlier. So several years ago, we got these credits for 1 year. Now you get it perhaps for 1 month, but it's enough. If you need another one, create another subscription and just try another project. There are a lot of ways how you can do that. So, guys, I think I just wanted to go there and just show you both of from the left side and also from the right side, because I don't want only to speak from machine learning, because the most of you are not familiar with .NET and machine learning. Because if you
have a problem in PowerPoint is not in place.
Is now from this update.
Some red ways which are not successful.
There are a lot of samples there. My favorite of this, because of my idea that I have done the sentence similarity.
Quantum approaches, try everything.
ML.NET.
I try every approach which I can do in parallel. That is the big advantage of quantum. You do calculations, every possible calculation in one step.
To get
no
two sentences,
calculation process.
Model, unknown sentences, and just to get how similar are they.
All the stuff is calculated in one time.
There are a lot of samples. If you like to check also from .NET, from GitHub, from
the value or the right way.
I can show you.
This means you do superpositioning calculation, which means that you put all your results together and the results just a boost.
Multi-class classification, recommendations, regressions, time series, anomaly detection, clustering, ranking, computer vision.
Yes, should be the right one. So that's all the problem why you need more than one qubit to resolve a logical qubit.
That's it from my side. Thank you very much. Thank you for being this with us. And this
how many classic can a 64 CPU process in one?
It was .NET Conf after party Germany. Thank you very much, Torsten, for hosting this.
64 qubits can
Thanks for the people in the room.
In one step.
Thank as well.
So can you imagine how fast you can calculate stuff with such ideas?
As all of you.
It's quite fast. A good example is, like I said before, the AES encryption. To break it or to calculate an AES encryption key, usually you need the moment something about 100 years. It's 2000 encryption. Quantum computer needs less than a second.
Or a Coke or a Marty.
Okay.
And that's
so, guys on the stream, we say goodbye until next time.
Use case categories for quantum computing. So you have optimization cases, you have simulation cases, and you have practical accuracy use cases. So there's that in the past that there might be there are post-quantum processing algorithm how to encrypt